Definitely learn and be familiar with it. I would only say like specialize in it if you really want to do language modeling stuff. There's lots of jobs out there for that, but it's by no means the only path.
Welcome to the Astronomers Turned Data Scientists podcast. I'm Joseph Ahern, and I've been a data scientist for over 2 years now.
And I'm Jeff Silverman, and I've been a data scientist for 7.5 years, almost 8. We're getting there. And our guest today is an old friend of mine from astronomy research days and a working data scientist, Kevin Moore. Welcome, Kevin.
Hi guys, nice to be on.
Could you start by telling us how you got into astronomy?
Oh man, sure. I mean, childhood love of space, like so many other people probably. I actually didn't really consider it a viable career until I was like partway through college. I started doing physics in undergrad, mostly because I had a really, really good high school physics class, probably not that uncommon among people who go down this path. But yeah, didn't really like realize that astronomy was a career path. I mean, I knew astronomers existed, but didn't really like give a lot of thought to doing it. And then slowly realized, oh, it's just physics in space for the most part. And I was like, well, I should consider this. And then, when I was in grad school, started working on kind of like a temporary basis with who became my PhD advisor, just being like, oh, I need to try a bunch of stuff. Really liked working with him and the projects, and then just, you know, sooner or later you just end up with a PhD if you don't pay attention, right?
So post PhD, what was your path? Because I know you had some career steps in there before moving into tech and data sciencey stuff.
Yeah. Yeah, I did a lot more than most of the people that I know who switched over to data science. I mean, the most common is you get your PhD, and that's a good transition point. It's a sensible place to go on. I did a postdoc for 2 years, and I was a professor for a year. I do know a few other people who have done that, but that's an extra 3 years in academia. I basically was not enjoying the job as much as I thought I would. And as time marches on, you're like, well, it's just going to get harder and harder to make this transition the more time goes by. Yeah, so I had some friends who had done insights, data science in the past, talked to them about it, got very mixed things. One of my friends like really did not like it. It was like, oh, it was so stressful. And some other friends liked it. I was like, I might as well try. So ended up doing that I think the session right before you, Jeff, summer of 2016. And so yeah, after a year of being a professor was when I made that switch.
I'm wondering if you could give a little more details about like landing your first position in industry, like what went into that besides just insight. Or I mean, was it that easy, or was there more work that you had to do to get that?
There was some more work. Yeah, yeah. I did feel easier than when I tried to do it completely on my own, mostly because I kind of had no idea what was going on in the industry. I didn't really know how to tailor a resume to jobs. I didn't really know what to expect in interviews, that kind of stuff. So Insight helped phenomenally in that. But yeah, getting the first job was just, lots of interviews. They have you go on, demo days to a bunch of different companies, and you basically get some interviews through there. You can get some through, your own external stuff. I ended up getting an offer and accepting it from one of the companies that came through Insight. So it was weird. It was a company that had been acquired by Salesforce. So it was called Salesforce IQ. They had already been acquired by Salesforce, but they had a separate interview process. So kind of like you were being interviewed at like the old startup that it used to be. They had like separate offices. They had like slightly different perks, like you got food and things like that. It was kind of, when Salesforce people found out about it, they were quite upset. But or like, hey, why can't we get that stuff? Yeah, so it was like kind of a slightly different interview process than had I gone through, main Salesforce interviewing. But yeah, I think interviewed at like 6 or 7 places. It was a lot. It was a very busy time.
you go into a little bit just sort of what you did there, and then you were there for a while, if I recall correctly, and then moved
Yeah.
on. So yeah, I'd just like to hear a little bit more about what kind of stuff were you working on, how that evolved over time, and then where when and where you switched
Yeah.
places.
Yeah, so like I said, the company had like somewhat recently been acquired by Salesforce. So it was all in a sense like outsiders to the company that like didn't really know a lot about how the internals worked, like relative to people who had been there for, years and years and years. And so that was the origin of the people who were building this like ML infra or like ML platform team that I was on. So I think just historically, because they had used a lot of the AWS stuff, they had some people with like ML expertise and the type of stuff they wanted to do. That's how that team grew out of there. But yeah, that's what I ended up working on. So I ended up working on a team that was building software and models for other teams within Salesforce to use to put machine learning in their applications. So things like making predictive lead scoring or customer case classification or predictive marketing type stuff. Lots of different use cases, but the goal was to have it all powered by the same underlying system for efficiencies of scale and all that good stuff. So it was kind of like a different position than the standards data science. It wasn't like I was doing a lot of analytics on an existing product and trying to find, pain points or trying to figure out like customer churn, problems or things like that. It was a lot of like, we're building a product. And so when I first started, there was no products, right? There was stuff that was being worked on. So there wasn't really any data science to do. There was like some data and there was a lot of like pipes that were broken and like just spewing data out into a void. So a lot of my first several months was just, helping fix up that, learning a lot about like the data engineering parts of the job is actually very, very helpful. I mean, when I remember joining thinking it was like, oh man, I'm really in the deep end. I'm at my first industry job. Everything was in Scala, which is not the most common language to be using as a data scientist. We were using it because Spark is written in Scala. And so it was like, okay, I have to learn Spark. I have to learn Scala. Scala is all about like functional programming. I have to learn what functional programming is. And it's like very different than the traditional like imperative stuff that virtually everyone that I know who's worked in scientific computing uses and learned. And this people can be very opinionated on how to do things, which paradigm is better. I personally just see these more as tools. So I don't particularly care too much about the paradigm. There's cool things from functional programming for sure, but like I'm not you know not married to it. Yeah, but it was yeah, very fast or like very steep learning curve at the beginning. And I had like a decent amount of experience doing programming and stuff beforehand, just not not the same type of stuff that I was doing in industry.
Do you still like to program in Scala, or have you changed from those days?
I don't have really the opportunity to, so no, everything I do right now is in Python. I mean, it's kind of like won over the machine learning wars. There's definitely some things that I really appreciated about Scala. There's like certain patterns of like, instead of doing loops, you do these like maps over data, and it can just be like a little more concise to type certain things. So yeah, when I was like going back, because I don't think I mentioned this, but I had been at Salesforce for a little over 4 years. And yeah, using almost exclusively Scala the entire time, a little bit of Python here and there. But yeah, going back to Python after that did feel like a little bit jarring. It's like, it felt comfortable because it's like, oh, I can kind of just like guess how this is done and it will work often. But yeah, it did feel weird. I wanted to do certain things that like you couldn't do. There's all this like typing stuff that is a lot more important in Java-based systems that you just don't really use much in Python. Although they do have types now. So
So I know a question that we get from folks a lot is how many different tools, platforms, languages do I need to know really well or be familiar with to get a data science job from academia? And the standard wisdom I think most of us give is like, learn Python and SQL and be pretty good at it, and that's about what you need. It's interesting, you coming out of academia, going into a place that's basically all Scala, and you had to learn that on the fly. I don't think it's abnormal for people to have to learn new languages to some extent or new platforms in a job, and those often aren't hard requirements or not the end all be all. But I'm kind of curious, was that intimidating? Was that something you sought out because it was interesting, or tried to avoid, or kind of came into it? And also just for a little bit of context, you are, I think most of the people we've interviewed were observational astronomers. I don't know if you're the first computational astronomer, but maybe I'd have to think back of all the folks that we've interviewed. But certainly, I know your astronomy work through, large scale simulation type stuff. So I think of you as a coder at heart. But I'm kind of curious how that experience also was reflected in your resume and in sort of the jobs that you looked at and interviewed for.
Okay, there's a lot I can say. Yeah, just to actually, because I didn't explain what I did in my PhD, I'll give like a very brief overview of what I worked on. So I did theoretical slash computational astrophysics. I mostly was working on stellar evolution, detonation physics, doing different types of like supernova modeling. So both modeling like the types of stars that could go on to die in various ways, so actually going through like the stellar evolution of those, and also modeling like like hydrodynamics, like what happens in like detonation waves that sweep across surfaces of stars and things like that. It was pretty cool. But it used just in case people thought I had like relevant coding experience, it used Fortran, and I was using Ruby like in the early grad school days, because this was before Python. This was like in the like, I don't know, 2008, 2009-ish. This was like before Python was like the clear winner in scientific computing. And so people were still like, oh, some people were using Ruby, some people were using Python. So one of the big plotting packages that I used was in Ruby. So I wrote a decent amount of Ruby, and like really didn't use Python much until the end of grad school. I kind of like did it on purpose because I was like, just preparing for alternatives. I'm like, I really want to like stay in academia, but it's good to know Python. It's clear that like Python is becoming more and more relevant. So I did force myself to use it the last like few years of grad school. But yeah, in scientific computing, it's basically like all Fortran and like C++. There's like a decent amount of CUDA these days if you're doing anything that's like based on GPUs, but that itself is typically C++. So yeah, the languages that I used, I had a lot of programming experience in academia, and even before. Like I mean, I'm the stereotypical person who goes into software engineering because I got to take programming in high school. I did, programming in undergrad. I didn't major in it, but I took a decent amount of like extra programming courses. So this is not like, just to be clear, this is not like just a quick pivot that I did. I did have quite a bit of background in it, so I was kind of seeing it as like playing to my strengths more so than like learning a ton of new stuff on the fly. Definitely had to learn new languages. Definitely did not know, the Spark distributed computing stuff when I was going into things. But yeah, going back to the earlier part of the question, like, did I like kind of seek this out? Like I did seek out a job that was more on the like engineering side. To be clear, I did not want to be a software engineer. I'm not particularly interested in like just doing software engineering. I'm more interested in like overall kind of like the simulation aspect. Like I really liked doing simulation stuff in grad school and postdoc, and I kind of see like machine learning as not the same, but it's in a similar vein, and it kind of like interests me in similar ways that writing simulations in physics did. So yeah, I was definitely seeking out a position that did that when I was deciding to go to Salesforce. That was basically like the thing that won me over. It's like, oh, I know exactly what, or exactly the type of thing I'll be working on, and aligns pretty well with what I want to do. It's obviously my first job, so I didn't really know that much. You can't really go too wrong, as even if you have like a bad experience, it's useful. It's useful in general. I think I forgot the second half of the question while I was rambling. So,
Oh, I think that covered my sort
okay.
of semi-rambling question. I feel like I tend to ask long multi-part questions. But no, I think that definitely covered it. And yeah, before we started recording, I recounted one of my favorite memories that I'll recount during the recording of like, I was studying for my interviews and I was like, studying coding and stuff like that. And there was, leak code questions around linked lists. And I'm like, man, if I get asked a linked list question in an interview, I'm just leaving. I don't want to work for that company. And I told Kevin this, and Kevin was like, I love linked lists. I want to be asked about that. So, different strokes, I guess, for different folks.
Yeah, I wouldn't say I love linked lists, but like I don't get quite as bothered by those questions.
I did simulations also in my research, but orbital simulations. Oh, so different scale. But one of the things that I've more recently come across that is done in industry is operations research, and that seems to appeal to people who do simulations. And so I don't know if you have any experience doing that, or I've also
I
just
don't, but
not.
I know,
Yeah,
yeah, I
interested in
know what you're
hearing.
talking about, like, simplex stuff and like constrained optimization and things like that. Yeah, yeah, I haven't actually, that's been something that's in like the back of my mind is like, oh, if I ever have a chance to like learn or use this, this would be like a cool thing to explore. But no, I haven't really had any serious experience with any of that stuff yet.
Okay. Do you have like a favorite project that you've worked on you want to talk about?
I mean, there's a lot of like interesting ones. I can say in vagaries, like the general ones that tend to excite me more are the ones where like we really don't know what we're doing. And it's kind of like, can't, it's the question is more like, can we do this problem more than like, can we make this 5% better? That's kind of the problems that you're more exposed to in doing a PhD in general is like, you're less optimizing things that are, I mean, it depends. It depends. Some things absolutely are optimizing things that already exist. That's very important. But like the more important questions are like, let's try a new domain or let's try like a new can we do interesting predictions here? And so it might be something where oh, you might have to learn some new technique like, graph neural networks or some embedding thing and to help you like solve the problem. So those are in general like kind of the things that I like the most. I mean, the stuff that I'm doing right now, we'll probably talk about some of that later. That's pretty interesting, mostly because it's a lot of like new things.
Yeah, I think hearing more about what you're up to currently and post Salesforce would be great.
Sure. Yeah. So after in fall of 2020, I went to Facebook, who was still then Facebook. I was there when they switched names to Meta. I was only there for a little bit, maybe a year and a third, year and a quarter, something like that. And then got the opportunity to work with one of my old coworkers from Salesforce, who was starting a company. And they they were like, "Hey, do you want to? Are you interested?" And I was like, "No, that's crazy. I can't join a startup. That's." And thought about it a little more. I was like, I should try this. This is like one. At least this was maybe 6 months before the whole ChatGPT stuff originally blew up. This is relevant because the company is like an NLP focused, like or the machine learning work is like very NLP focused work. And I was thinking at the time, it's like, well, you don't often get the chance as like a data science or like machine learning person to be like one of the first. So I was like the first hire by the team, like, 2 weeks before the first engineer joined. So we were basically the same time. But like usually the pattern is in startups is like you'll get lots of software engineers and maybe some data engineers. Then later there might be a reason to have machine learning there. There might be a reason to have data science there. But this was something where it's like, okay, no, the core product is like powered by ML. So it's not going to be like an afterthought or it's not going to be a nice to have. It's going to be like, you're in the critical path of the company, which is usually where you want to be. It depends. You can have fun all over the place, but your job is a little more secure if you're in the critical path of the company. So I felt this is kind of a unique opportunity, so I took it. And yeah, things like rapidly changed after like 8 months or so. ChatGPT comes out, everyone's like, AI's exploding, everyone's trying to do kind of like similar stuff. So yeah, maybe if I had like waited a year, there would be a lot more like startups that wanted to hire, ML people as part of like the founding team. But at the time, it seemed kind of unique. And yeah, I can tell a little bit about like what we do. If that's yeah. So yeah, the company is called QN, and it's basically doing a lot of like customer experience optimization type stuff. So this is a lot. So the ML work that I'm focused on is things around like conversation understanding. So figuring out like what's going on in customer support conversations. How can we make these better for the customer? How can we make these more efficient? How can we make the bots less bad, which they're often pretty bad. And so it's a low bar. So yeah, there's a lot of just trying to like squeeze information out of conversations, thinking about like what is important for people at these larger companies that are running customer support departments. Like what do they, what's most useful for them, what helps them make decisions and improve their own product. So yeah, in a sense, it's kind of like Salesforce in that like it's like a software as a service, I guess, under the hood. Like our customers are other companies that are managing customer support teams and things like that. So I've learned, yeah, quite had to keep up quite a bit with like all the goings on in the recent like LLM craze. Because we're like knee deep in that stuff. Um,
Being one of the first hire or the first hire, well, how big has the company grown since then?
I believe we're like 11 or 12 people
Okay. All
now. I
right.
should know because it's like almost countable on one hand. I'm not gonna like, perjure myself and say it's around a dozen.
Yeah.
Uh a dozen.
Okay.
It's grown quite a bit. Yeah, it's
Hmm.
so it's it, it actually mirrors a little bit of so my first position when I was at that team that was kind of inside Salesforce that also felt a little bit like startup-y within a big company because again it was all outsiders in the sense that like it was all people who had not been at Salesforce for a long time, working kind of on a coherent product and in kind of like a growth phase. So like when I joined that team, it was like in the upper 20s, I think, of people. And when I left, it was like 120, 150, something like that. It was a huge org when I had left. And so it was like, a few years displaced from where I am right now, but also similar, like, oh, we've got to like build everything, build the plane while it's flying type stuff. So some of that, was actually kind of surprisingly similar to, or like some of the stuff in my current position is, surprisingly similar to that. But yeah, plenty of differences too. Yeah, it's my other two jobs were both like large companies. So, very
So
different.
have you been involved in interviews to hire the people who came after you
Mhm.
and so like how did you go about interviews? Like what maybe I guess it depends on what position you're hiring for, but if there's anything relevant to our audience of aspiring data scientists that could be helpful for doing well in interviews.
Sure. Yeah. I have done, a bunch of interviewing at all three places that I've been, kind of similar style interviews. So I usually either do like the coding section or kind of like we'd call it like the ML case study or ML systems design type interview. So this is like you're given a problem and you kind of have to walk through like how you would go about solving it. Like, oh, you want to predict like it's basically the data science or machine learning version of the systems design. So instead of like designing Twitter or designing Google Maps, it's like how would you go about doing like this type of prediction or like, lead scoring or, customer case classification or something like that if I was at Salesforce or, something more Facebooky if I was at Facebook. Yeah, I was trying to ask stuff that's like somewhat relevant to the company that I'm at and the type of work that we're doing. I mean, you can go about there are plenty of places that will just ask you like straight CS 101 questions. So like Facebook in particular was very big on just straight CS 101 questions like, okay, go through the tree in this traversal or do this problem that's really like a graph a topological sort or something like that. So if you're going down the path of applying for a more like machine learning engineer side of data science jobs, then yeah, you'll definitely want to like familiarize yourself with the standards, leak code, hacker rank problems that will get asked. You'll probably see things from like easies to mediums on average. You can see some hards. I mean, it depends on the place. Yeah, the interviews that I would typically do for the coding stuff, the things that we'd look for would be like, do you have like just a general like, do you know what you're doing, right? I mean, it's pretty clear when you're interviewing someone if they are competent at coding or not. The place where you might like split hairs would be asking about like, oh, you've solved the problem. Are there any ways of making this more optimal? Are there any ways of, or like, you know, tell me about the runtime. So like, most software engineers who will ask you these interview questions will want to know something about like big O notations. So like what's the overall runtime of this? How efficient is it? They'll often put like constraints on it at the end, like, oh, what if you didn't have this? Or what if you had this other constraint? How would that change things? That kind of stuff. So not just knowing how to go through the problem, but also, having enough experience that it's, you don't just rigidly know how the problem is solved. You also know how it's related to other problems and how, like, changing different assumptions will change how you approach or how you go about solving it. That's most of it for the coding. For the like case study systems, ML systems design type stuff, it's more, do you have a good grasp of like the machine learning life cycle? So do you understand how to, yeah, I mean, very basic. Do you understand how to like train and evaluate models if you're going about doing models? Do you understand balancing? Is inference cost more important than like like is it worth going for like a smaller model because you'll be doing like 99% of your work in inference, or is it really important to have like a giant model because it's like a very mission critical thing and it's like offline and it doesn't need to be as fast? Yeah, so like offline versus real time can be an important point, but it's generally, there's not like a right solution. So I'm not really typically looking for people to like, put, oh, the right algorithm, like great. It's more like you can kind of use anything. Do you understand like sensible baselines? So if you're trying a fancy model, are you going to try something simple before that so that you can compare it to, and also so that you can just have something that you can push out if you need to? And yeah, do you understand like how to do feature engineering? If it's kind of like a standard problem, do you understand like what the common approach? So if it's like a text modeling type problem, are you familiar with like embeddings and transformers and things like that? Kind of like the standard approaches to some of these. Um, Not to say that you like have to use them, but just assessing kind of familiarity and similar types of follow-ups, like, oh, what if you like wanted to do this other complicated thing, or what if you didn't have this type of data, or what if you wanted to pull in this other type of information? Those are like kind of common follow-ups you would get. I usually let the interviewee kind of direct it a little more. So if they go in certain directions, I might ask them. So I'm like, you're really interested in like model interpretability and understanding type stuff. So if people go in that direction, I will usually have follow-up questions about that because I've done that a lot in previous positions. So, but yeah, just I don't know, hopefully that was helpful.
Definitely. Yeah.
Yeah, a lot there. I kind of want to circle back to a couple of points. I think, first things first, like many questions we get, the answer is it depends, right? Like not everybody's coding interview is going to be the same. Not
Yes,
everybody's
yes, for
ML
sure.
case study interview is going to be the same. Plenty of positions won't have an ML, as in
Yep,
depth as you're talking, right? Depending on the type of role.
absolutely.
For the ML case study, the sort of the type of interview that you were just talking about, I'm curious what the split is between like actual writing of code versus sort of just verbal description and back and forth. Because I've had a few different flavors of this where I've been asked to kind of pseudo code a clustering algorithm,
Mhm,
and
mhm.
that's a good way to prove that I understand how it works, but it felt a little in the weeds, whereas I could have described it in words just as well and shown that I understood what was going on. So I'm kind of curious, what you've seen and what your take is on that, because I have also heard people concerned, like, do I have to memorize the cost function and how to code that for like gradient descent? And I'm like, I guess somebody could ask you that, but I sure hope not.
Yeah. So like you, I have also had kind of experiences all over the place with what level of how these questions are asked. I can tell you that personally, I do not ask even for like pseudocode. It's like it's very much, I mean, a lot of them virtually all of them recently have been remote interviews. When we used to do these in the office, back when I was at Salesforce, we would have whiteboards so they could like write out things on whiteboards. None of those tools are really that good for remote interviews in my experience. Or it's like, I'm sure there are some, but I just haven't had people really want to use those, and I haven't really wanted to use them myself. So it's mostly been discussion. So like this, so I'll ask probing questions, but I won't really ask anything that's at the level of detail of like, how would you actually implement this? Mostly because we have separate interview sessions that are more on code. So we either have like, a data exploration session where they'll go through, and do, here's a data set, go through and do some analysis or do some like, train a model to do X, Y, Z. Or there'll be like a coding question where it's like, okay, actually like write out the code and run it in front of us. So yeah, usually in the case study, we're not actually looking for, it's more thought process and design and higher level understanding stuff that we're looking for. Because you really don't always get those signals I mean, you often don't get those signals in coding pieces. So you've got to get them somewhere. So I've had all sorts of experiences in those. I've had ones that are very similar to how I ask it, where it's just, please discuss this. I have actually at that one place back when I was in Insight did actually ask me to implement gradient descent for like training a neural network. I was like, really? Okay, sure.
I
And
don't know what signal
did.
they're getting out of that, but okay.
Yeah, I was like, all right, I'll do it. But that was an outlier. Most of the places that I have interviewed that have asked these types of questions have not ever asked like, how do you do X? Because it's less useful on their end if like, oh, do you know how like dbScan works? Like that's kind of a random, yeah, you might if you've used it before, but like if you haven't, who cares? I have been asked like how to go about writing, I think something like k-means also in an interview, because that's kind of like a little more easy to explain if someone hadn't. I mean, you should probably have seen it if you're going through these types of interviews, like the more coding side ones. Yeah, I have had a few implementation ones, but for the most part, the coding ones have either been like, here's a coding question that's like kind of related to the company, or just probably, 60% of the time, here's just a CS 101 type question that's not at all related to what the company does. It's just like, hey, here, like do something with a Markov chain, or like do something, like I said, with like a graph traversal or something like that, where it's like, yeah, this might be useful, or it's like I've had like implement pieces of sorts before. So I think like one of the interviews I had somewhere was like do the merge part of merge sorts, but not like do the whole thing. Yeah, there's stuff that's all over the place. So yes, it definitely depends, but the signal that I'm trying to get out of coding sessions is more just like, are you familiar and competent at coding? And I'll ask like some follow-ups, and the stuff from the case studies is like, do you have good high level design understanding for how these systems would work? And again, depending on the level that you're interviewing for, there's like way different emphasis placed on these different ones. So if you're interviewing for like a manager position, you will likely see stuff that's more like the ML stuff that you'll see might be more on like the systems design end, because you will be a lot more working with that side of things than you will be with like, implement like, attention or something in Python. Whereas if you're, if you're going for a kind of an intro or entry level like machine learning engineer, absolutely, like, implementing intention might be a very relevant question. I don't know if they would ask, specifically do that versus a CS101 problem, because I haven't gone through any of those interviews, but it's kind of all over the place.
One question that we've gotten from a couple folks is specifically about the coding interviews, and I think this may apply more to smaller companies. In my experience, Sometimes, especially at larger companies, the coding interview is by a data scientist, right? And that's fine, and they know what they're looking for. Sometimes it's from a data engineer, so they're sort of data heavy, but they maybe know a little bit more coding and engineering stuff. And then sometimes it's just straight up software engineer, CS, full stack, backend, whatever. And so going through this from both sides, what's your experience with the different, I guess, backgrounds of interviewers, which oftentimes people do, when you're interviewing at a company, for our listeners, like a lot of times they will give you information about these are the different sessions, these are the topics we're going to cover, and often they will give you the name of the person or at least their title. So you have some idea of their background. You could, stalk them on LinkedIn and see where they're at. I'm curious if you have advice for people on should they kind of switch how they answer or tailor their responses to sort of the background of the person, or is it really just they should be as prepared for sort of the level that they think is appropriate for the role? And if that's not up to snuff to a CS person, but would be up to snuff for a DS, that kind of is the luck of the draw or a roll of the dice. I'm curious how you see that.
Yeah, that is like a somewhat of a consideration, I guess, is like, yeah, who is giving the interview. At larger companies, they will try to align and have no matter who's. So yeah, I was interviewed at least for the Facebook position by both like data science and software engineering people. Internally, they're supposed to like try and align and like evaluate you the same, but of course, it's different people, even if they did have the same title. It's, interviewing's to some extent a crapshoot, depending
Sure.
on like who's who the pair of people interacting is. I don't personally try and like tailor the answer to the person more than I like kind of tailor my expectations of what I will be asked. If a software engineer is interviewing you, you will more often, I guess, get the CS 101 treatment where it's like, here's just a problem divorced. I mean, this is very general. Like, I don't want to paint all software engineers with the bad brush here or anything. But I would expect, I guess, more of a like algorithmic focused question. So the question will be phrased in a way where it's like, oh, you won't realize this upon first reading it, but the solution to this is like a graph traversal, or the solution to this is like dynamic programming. And this is like you probably the most frustrating part of preparing for these interviews is there's just like a lot of different types of solution methods for some of these. And it's really hard, if you're not used to doing this, it's really hard to get used to this or like kind of recognize what approach is the quote unquote correct or like kind of near the optimal approach for different questions because they're often phrased in a way to like make it not obvious. It depends on like what level of difficulty they're asking you. But it's one of those things that like honestly you just need experience and practice to get better at if this happens to be something that you're struggling with. But yeah, software engineers will often, yeah, they would probably more often ask about like big O notation and more often ask about maybe optimizations. I mean, they themselves will probably be more familiar with like the different ways that you can solve a problem. They might bust out more esoteric data structures or things like that, or at least they'd understand them. But yeah, I wouldn't really like tailor the answer any differently. I mean, usually the goal is to get the same kind of information out. It's like to understand, does the person understand how to code and do they understand trade-offs and, various places where things can go wrong? Can they like correct, it's okay to like make mistakes while you're doing this. Can they like notice their own mistakes and like self-correct? That's usually things that you're looking for. So in terms of like doing the problem, no, I don't really think I'd tailor it too different. Sorry, I also forgot the second half of the question again. I think that was just the
No,
first.
I think that definitely covers it. I mean, that's sort of what my curiosity was, and I think what I've heard,
Mhm.
a couple people asking about.
Mhm. Mhm. But often, yeah, I was just saying, often I don't know. I would say not all the time, maybe like half of the time I've known like who's actually giving the interview. But yeah, I mean, it doesn't hurt to know and stalk them a little bit, I guess.
So you mentioned that your current job is somewhat NLP focused and knee deep in LLMs. How do you see this evolving in the next year or two? And any advice for maybe different focuses for people who are just trying to get into the field for the first time?
Yeah. So in terms of where it's going, probably in the near term, in like a year, it's probably just going to be like more efficient versions of what we have. So stuff that was harder to do will probably be easier to do locally. Models will be probably a little bit smaller, a little bit more capable. I mean, so right now we're kind of already in the situation where groups that, it's expensive to make these base and instruction tunes, LLMs. There's a whole bunch of open source ones to varying degrees. Yeah, there's all sorts of like weird licenses that have popped up. But yeah, the capabilities of the ones that you can run and fine tune locally are only getting better. So I would assume that that would continue for a year or so. There'll probably be more libraries and tooling around doing this. There's already lots of different libraries that people use for like fine tuning this stuff. There's a lot of the stuff that we use is from Hugging Face. They have like this TRL, Transformer Reinforcement Learning library that has a lot of just like easy, easy hooks into various complicated fine-tuning procedures. So whether or not you're just using supervised fine tuning or one of the like human preference alignments things or like full reinforcement learning, you can kind of use the same library for that. So there'll probably be, more of that. There'll be a more obvious like standard library to use, kind of like how PyTorch and TensorFlow, or more PyTorch now these days, are the standard libraries for doing neural network development. You'll probably have more robust standard libraries for this stuff. Evaluation is like really difficult, probably the most difficult of all this new stuff. And so there's constantly people making new evaluation data sets, new questions like, oh, I found something that the models can't do. There has to be something that like, separates us from the models, which there are plenty of. But there's just this like constant evolution of evaluation benchmarks. There's like a lot of the ones for just general chatbots are like, let's ask another chatbot, or let's ask some like fine-tuned reinforcement learning model to like evaluate the win rate of model X versus model Y. So there will like hopefully be more robust ways of doing that. GPUs are only getting faster and more available. So like, you probably will still have trouble getting the most recent ones, but last year's amazing cards will still be like very useful for people who are fine-tuning small models and stuff like that. So at least on like the model development front, those things will probably all improve. And I guess like, just the general capabilities of these closed source API models like ChatGPT and Google's Gemini is the most recent one. Yeah, Gemini Pro Ultra and Claude's, like those will all get better. They're already quite impressive. But they'll just keep getting better. I don't know. Without like specifics, there's a whole bunch of things you can do with these. Like you don't need to, fine tune these for all the different things you want to do. They're getting better at instruction following. When I was first working with these, getting them to just like output JSON, for example, or output like systematic kind of like constrained output that you can feed into later systems. That's a lot of time how people want to use this, is they want to embed some like automatic processing thing, like, oh, I want to understand what's going on in this like big text document. So I want to like summarize this, or I want to find out when in these like contracts or law documents this happens, or when in these like medical records like this other thing happened. And so you'll want to like put something like that in your pipeline. Well, you've got to like have some way that the output is recognizable by some later downstream process, because at some point you're going to put something in a database, or you're going to group by something, or you're going to want to show something in a UI. And so you have to have some things be standards. And so the ability for language models to do that in kind of like, or was it 2022 when this all exploded, is like much worse. But it's now quite good. So the instruction following abilities of these models have gotten pretty wild. There's still plenty of things they can't do. Let's be clear.
So we're getting towards the end of our time together, but one sort of last question I want to ask, based off of that view of LLMs, and they're awesome and they are a lot better and they're going to continue to get better. Where do you stand on advice for people, in academia, interested in getting into the tech industry? Should they drop everything and become expert prompt engineers because that's the only jobs that'll be existing in 2 years? Is there, do you think there's going to be a lot of those types of jobs, or LLM, NLP related jobs, but there'll also be lots of other flavors of data science jobs? I'm currently in that camp still. Is it a fun thing to do on the side? Is it, hey, you should focus on this for the next 2 years because it's going to be incredibly hot and there'll be a ton of jobs? Where do you fall in that sort of spectrum?
Yeah, I mean, it depends on what you want to do. If you want to focus on language understanding or NLP type stuff, yes, you basically are going to have to be familiar with these and learn these. It's kind of, I mean, just knowing how to write prompts and interact with these models, I think is like universally useful, no matter what you're doing, even if you're not doing like data science, or even if you're like, no matter what job you're doing, if you're dealing with like text at all, that will probably help you in some amount. But in terms of like our other job, like our other parts of like data science going away, I mean, not really. There's still all the same types of things. Like we don't have like AI coworkers yet. I feel like we're pretty far away from that. I don't know how, maybe 5 years later you'll listen to this and be like, wow, what an idiot. But it doesn't feel like it feels to me like the transformer paradigm does have kind of like, a soft ceiling on how well these models can get. And we'll need some more developments before they're really like, actually doing our jobs. So a lot of the like machine learning stuff that I was doing in the past, people are still doing. I mean, like building like recommender systems still exists. The entire like huge amount of ML that goes into like ads work is still there. I mean, LLMs are helping doing like feature engineering and stuff like that, and they're helping you, right? You can better understand what's going on in a picture. You can better understand what's going on in ad copy. So those will be integrated into the systems, but like there's much, much more to that than just the LLM piece. And if you're interested in more of like the infra or data engineering sides, I mean, that is like it's more, I don't know, more difficult than it was before, because now you have these like language models that you think are doing, it's like, oh, I'm trying to get them to always output this certain thing, but now I have to put all these checks. Now I have to like argue with the language model to be like, no, please put it in the format that I want. And like, 99% of the time it will. That stuff is all still there. I don't really see, the only thing that's like going away really is just like the older models that people used to use in place of LLMs. So like using like just embeddings or using like TF-IDF or things like that. You can actually there's still places for that stuff. It depends on like what you want to do. If you need something that's like extremely latency sensitive, you can't just like throw things through a giant LLM always. It depends. It's another new, like very important, like very powerful tool, but it's not like, the one tool that must always be used in the same place, or in different places. So yes, definitely learn and be familiar with it. I would only say like specialize in it if you really want to do language modeling stuff. Like you don't, you know, there's lots of jobs out there for that, but it's by no means the only path.
Thanks so much, Kevin, for joining us, and thank you for listening to this episode of the Astronomers Turned Data Scientists podcast.
Yeah, thanks for having me.
Like and subscribe to the channel, the podcast, and you'll find out when we drop new episodes. But yeah, thanks again, Kevin. Appreciate it.
Thanks.